Hi, I'm Ben Gromyko from InterNACHI. Every home and building should be inspected by an InterNACHI certified professional inspector every year as part of a building owner's routine maintenance plan. In this video, we're inspecting the foundation of a house built in a coastal area. It's a beautiful house on the beach, but there are defects that require correction in this house. We'll also be inspecting the pier that's located right next to this house. This house was built on the ocean coast, and its foundation is made of wood framing and wood piers. To inspect the house foundation, we're going to reference the International Residential Code. Now, home inspectors are not code inspectors, but knowing building standards can help a home inspector do a better inspection. Inspection of fasteners and metal connectors is very important and should be a regular maintenance activity undertaken by owners of buildings and homes located in nearshore coastal environments. Since many homeowners may not be aware of the effects of corrosion and rust on the fasteners in their homes, communities in coastal areas should communicate to their citizens the importance of routine inspections by certified professional inspectors and the maintenance of foundations and their connectors and fasteners. In this video, we're also inspecting the metal connectors and fasteners used in the construction of coastal structures and houses, areas using preservative-treated lumber, and any locations subject to contact with floodwater or windblown rain. Structural failures frequently occur at connections rather than at framing members. And in coastal areas where higher moisture and humidity levels exist and buildings are exposed to salt spray, like at the beach, corroded metal connectors and fasteners like nails, screws, and bolts have been observed to contribute to the loss of an adequate load path. Now, the loss of an adequate load path often results in damage to or failure of a structure. And in general, 1- and 2-family homes in coastal high hazard areas or ocean hazard areas should be constructed on a pile foundation of wood or concrete. Round timber piles must be at least 8 inches in diameter and have a minimum tip diameter of 6 inches. Square timber piles, like we have here at this house, must be at least 8 inches square. So during an inspection, I'll take a look at these piles. I can't see how deep they are embedded into the ground below the finished surface, but these are 8-inch piles, and 8-inch piles are used in this foundation of this beach house all throughout the foundation and also at the deck structures above us. Now, piles supporting uncovered stairs, uncovered walkways, and uncovered decks must be at least 6 by 6 inches if square. If round, the tip, that's the part that was driven in the ground, must be at least 6 inches in diameter. If the piles are supporting uncovered stairs, uncovered walkways, uncovered decks, less than 5 feet above the grade, then the piles can be 4x4s. That's what we have here at the deck here in the front, going towards the beach. The pile tip must extend at least 8 feet below the natural grade or finished grade, or whichever is lower, and that's impossible for a home inspector to find. The maximum center to center spacing of wood piles must be at least 8 feet on center under load-bearing seals, beams, and girders. If seals, beams, or girders are attached to the piling, a minimum of 2 5/8-inch galvanized steel bolts per beam member must be through-bolted at each piling connection, like here. When a piling is notched so that the cross connection is reduced to below 50% or is top-bearing, then the seals, beams, or girders must be attached using a strap that is 4 inches wide by 18 inches long and 5/8 inch thick, and it has to be hot dip galvanized, one strap on each side bolted with two 5/8 inch galvanized through bolts. Now, we don't have that here. We have some load bearing, we have a notch, we got the through bolts galvanized, looking okay, but no straps. So what's a strap look like? Well, here's one. Let's take a look. And it's the wrong size. So here's a load bearing pier. It's got a connection, two bolts, 4 inches, not 18. It's thick, looks galvanized. Not concerned about the corrosion. Are there two straps? No. And the material of that bolt, those bolts are gone. The zinc coating has opened up, cracked, and now the material of the bolt is in question. Here's another strap. So we got load bearing, got a strap, but it's not to code, not to standard. I'm not a code inspector, but I know that part. So I'm going to call that out. What we need is, here's another strap, that's good, but there are actually parts where there are missing straps and the bolts are in terrible shape. Talking about corrosion of fasteners, nails and bolts, this one's pretty much shot. This is a major defect. This is a weakened area because of the corrosion and deterioration of the actual metal steel material. Some surface corrosion of the zinc coating is okay to see, but when that's gone, then the actual material of the steel will start to be affected. And for example, these washers are gone and the bolts are starting to just deteriorate apart. So this is a major structural defect. It's probably half a dozen of these so far that I've seen. They can be replaced, and there's some guidance in the code on how to replace these bolts. And it's expensive to do. But when you're at the coast, routine inspections for major structural problems like this is really essential. Taking a look around, I also see there are some ends of some load-bearing joists with fasteners, nails only, no bolts, and not enough bolts here. And the ones that are here, they're corroded. So that's a load-bearing component on top of a pile. Now, the corners of piles, well, the corners of the framing, like the floor joists, must be connected to a pile, and there has to be a strap bolted with two 5/8 inch galvanized through bolts, and there has to be a steel angle on the interior of the corner, an L4 by 18 by 3/8 inches thick, with two 5/8 inch galvanized through bolts. So let's go to our corner and see if we can find one of those. And I actually don't see any installed. I'm looking at the corners. Nope. I see straps, but at the corners I don't see any angles. So we need angles at the corners where the framing is attached to a pile. On the interior side, there should be a very large steel component, galvanized and bolted at the corner, and a strap. If the clear height from the ground to the seal, beam, or girder is greater than 10 feet, or the house is more than 1 story above the piles, and this one is, the pile foundation needs to be cross-braced. There should be at least 2 consecutive bays of cross-bracing in several areas of the pile foundation. So let's go down underneath the structure and see some cross-bracing. And I recall seeing some cross-bracing already, so that's good. But there might not be enough. Okay, so there's cross-bracing you could see behind us. and along here, and along the front. Sorry, I'll move the camera slower. The issue is it's not consecutive. They're on these rows here, which is good, right? But what we really want to see is along maybe 2 in a row or 3 in a row bays, right? And there's more to the front deck where there isn't a load-bearing component like a story. Above us here is 2 stories, a 2-story house, and there's no cross bracing in this area of the foundation. So we need some cross bracing. And while I'm here, I see a load-bearing beam. Just follow the beams and look for corners. So there's a load-bearing beam here, coming across, and coming over here. And there's some kind of connection or something to a piling. But here's the piling, right here, right? Load-bearing, and it's a 4x4. A 4x4. At this point here, and it's on 2x4s down there, and you can see there's some cracking. So that 4x4 needs to be an 8x8 because that is a corner right there as a load-bearing component. So we have some major structural issues, and wouldn't blame the homeowner for not knowing. A lot of people just don't know. That's why every home and building should be inspected every year as a homeowner's routine home maintenance plan by a certified professional inspector who knows what to look at. Okay, so let's keep going around and see what else we find. In the coastal hazard area and the ocean hazard area, all metal connectors and fasteners outside of the conditioned spaces must be hot dip galvanized steel and meet ASTM A153. There's also an ASTM 123. Exposed metal connectors such as straps must be at least 3/16 of an inch thick, hot dip galvanized, and meet ASTM A123 and ASTM A53. Stainless steel connectors can be used in certain locations too. The International Residential Code, the IRC, has specific building requirements that are related to connectors and fasteners in coastal areas. There's a section 317.3.1 about fasteners for preservative treated wood. There's a section of code that requires all fasteners used for pressure treated wood to be corrosion resistant. Now, specific requirements for connectors are outlined in that code in the IRC. The coating type and weights of connectors shall either be specified by the manufacturer or meet the minimum requirements specified by the International Residential Code. And there are exceptions to this requirement, and they're outlined in the code. Section 322, structural systems, require that buildings and structures be designed to construct and resist flood forces during a flood event. This includes connecting structural systems and anchoring the building to resist flotation, collapse, or permanent lateral movement during a flood. There's another section in 322.1.8, flood-resistant materials, and it requires materials to be used below the required design flood elevation. They have to be flood damage resistant. In light frame construction, structural elements are often connected with metal connectors and fasteners, and they include screws, nails, and bolts. Metal connectors and fasteners are important elements in transferring loads from natural hazards like flood, wind, seismic through a building. Corrosion rates for metal are dramatically higher in coastal environments than in less harsh non-coastal environments. Therefore, it's important to increase the corrosion protection for metal connectors and fasteners in coastal environments. Now, studies have shown that stainless steel and thick hot-dipped galvanized G185 or higher metal connectors and fasteners improve corrosion protection. Selecting metal connectors and fasteners made from the same metal and either hot dipped or galvanized or stainless steel will improve performance. Regardless of the metal that is selected, routine inspection is important to identify when replacement is necessary. Preservative-treated lumber, which is commonly used in many buildings, requires special attention when selecting connectors and fasteners. Light gauge metal connectors are commonly used in several locations throughout wood-framed buildings. Light gauge metal connectors are often used to create a load path by securing roof framing to the tops of load-bearing walls, connecting walls of upper floors to lower floors, and connecting walls to foundations. Corrosion of metal fasteners and connectors is accelerated when a certain level of surface wetness is exceeded, initiating electrochemical reactions among metals, salts, and air. The major factors that contribute to accelerated corrosion rates are proximity to the shoreline, high temperature, high humidity, elevation, exposure class, and certain air pollutants. It's helpful to understand these factors that contribute to corrosion so that appropriate design, construction, and inspection and maintenance activities can be implemented. When waves break, salt water is aerosolized, and the wind tends to distribute the salt spray to inland areas. The amount of salt spray in the air is greatest near breaking waves and declines rapidly in the first 300 feet, 300 to 3,000 feet landward of the shoreline. Tests in North Carolina found that samples of iron corroded 10 times faster 80 feet landward of the shoreline than samples of the same material 800 feet landward of the shoreline. And similar results have been noted all around the world. In corrosive environments, most construction materials deteriorate with time and eventually need to be replaced or repaired. In the United States, the service life of a wood frame building could be 50 to 70 years or more. With continued maintenance and periodic upgrades, buildings can remain serviceable well beyond that time. However, lack of maintenance and repairs can cause homes and buildings to deteriorate much sooner than the average service life. Buildings and homes located in coastal environments like this one, where steel components can corrode at high rates, are particularly susceptible to deterioration if not inspected and maintained regularly. Continued use of a building or a home over its service life requires that periodic inspections and routine maintenance is conducted to extend the life of the original materials, and the original materials are durable enough to last the expected lifetime of the building and house, and materials that have deteriorated are replaced. Now, replacing corroded connectors. Replacement is the only option in existing buildings where connectors have already been damaged by corrosion. It's recommended that replacement connectors have different sizes or shapes or be fastened in different locations so that connections are into undisturbed wood. Since the availability of such locations to attach replacement connectors into undisturbed wood may be limited in an existing building, it's imperative that the most corrosion-resistant connectors and fasteners possible be used to minimize replacements over the life of the structure. Inspections may also indicate a need to install connectors where there were not previously installed connectors. For example, an inspector may say adding a roof uplift connector like a hurricane clip can improve wind resistance and is generally worthwhile even if some dismantling of the materials in the existing building is needed to gain access. Now let's take a look at that pier that is located near the beach house. So I'll walk underneath the pier on the sand, and the first thing we see are those cross braces. That's good. There's some recent repair and improvements being done. The 2x12s were installed and bolted with a single bolt. You can see the bolts are relatively new, and the bolts of the new cross braces are in good shape. This board cross brace cracked, so that isn't any good, and these two boards are missing, so the cross braces are missing there. And here's just one example of some repair that is needed. There are so many bolts installed in this beam. The wood is actually cracking and breaking open. It's lost its actual material of the wood. And then when a new bolt is installed next to an old one, you could see the hole of the new bolt is very large because of movement. So the material of the wood is defective. So you can see the years of patching and installing new bolts. But the point is that when you see corrosion on the outside, what is the condition of the bolt going through the wood? Well, here's the answer. So the bolt going through the wood is in the same condition as the washers and the nuts and the bolt end on the outside. So when you see that condition on the outside, then you can assume that the bolt going through the wood that you normally can't see is in the same condition, if not worse. So it's unreliable. Material defect at this bolt. See, on the outside, the bolt, the washer, the bolt end, the nut is all in poor condition, and so is the bolt going through the wood that you normally can't see. It's the indicator of the condition of the entire bolt. Fastener is in very poor condition. As you can see here around the bend, these are in terrible shape. That bolt is defective. Inspections of foundations and their fasteners and connectors is important and should be a regular maintenance activity undertaken by owners of buildings and homes, especially those located in nearshore coastal environments. Every home and building should be inspected by an InterNACHI certified professional inspector every year as part of a building owner's routine maintenance plan. I'm Ben Grimico from InterNACHI. That's the International Association of Certified Home Inspectors. And I'll see you on the next inspection.